Good morning, everyone. My name is Chuck Clarisi. I'm a senior account manager here at Efficiency Vermont. I work in large commercial industrial markets. I work pretty closely with the folks in our programs team, including Bryn, Lisa, Steve Casey, and others. That includes the supply chain team. We're excited today to announce two new programs, the VFD contractor incentive and the IE5 motor rebate pilot program. This presentation should take about 25 to 30 minutes. Feel free to put questions in the chat or stop me anywhere along the way. I can't see hands raised, so I'll rely on either you, Lisa, or you, Bryn, to flag me with any questions as we go through. Let's get started. If I can advance my screen. There we go. So the first program is the VFD contractor incentive program. Second one is the IE5 motor rebate pilot program. I'll spend about 10 to 12 minutes on each and allow some time at the end for questions. Let me minimize. There we go. So we have had a VFD rebate program for quite some time, since 2016. We had massive uptake in VFD incentive program in 2016, 17, and 18. It's fallen off a little bit and plateaued since then. As the program team was getting ready for 2023 and looking at which technologies that we really wanted to highlight and promote more in the marketplace, VFDs rose to the top of the list. Pound for pound, I've always said VFDs are one of the best technologies we have for energy savings. The reason for that is that there are a lot of pumps and fans out there. These are centrifugal loads that when you slow them down even a little bit, the savings is cubic because of something called the affinity laws. When you slow a centrifugal motor down 10%, you save 25% in energy. When you slow it down 20%, you can save 50% in energy. So this is very high impact technology. There is a lot of motor load out there in the marketplace, and we'll talk about some of that in a bit. So this program was designed to increase adoption of VFDs in Vermont. I have walked through many boiler rooms and attic spaces and noticed a lot of pumps and fans out there that are still eligible for VFDs. If I had to estimate, I would say across Vermont, we're somewhere between 10 and 20% in terms of market penetration for VFDs on motors that could accept VFDs and take advantage of energy savings. The contractors in the marketplace, many of you on this call and others, are really ideally positioned to discover, install, commission, and maintain these VFD projects. So one of the aha moments I had last year was walking through a boiler room at a ski resort. There are a variety of chilled water and hot water pumps in that space. There are tags from the mechanical contractor all over the place in terms of being the service agent. And I realized, having been a mechanical contractor myself, the staff of these firms are in these rooms regularly doing PMs and repair work. And, everybody's been really, really busy, especially coming out of COVID and catching up on facility visits that they weren't able to get to during COVID. So they're walking past these opportunities every day. It stands to reason they're busy. So nobody's taking note of adding VFDs to these pump loads in this example. And I thought to myself, well, what if we had an opportunity to put a promotion out there that incentivized contractors to find these opportunities, let us know about them, and then work together with the contractor and the customer to make these projects come to fruition. So that was the background for this program development. The initial rollout has been pretty favorable, and we'd love to hear your feedback as we go along. This should grow your business. So again, the typical PM scenario, tech or two goes into a boiler room to do some tune-up work or replacement work. And oh, by the way, they just noticed there's 50 horsepower worth of VFDs in the room. They flag that opportunity to us. That becomes a new a new project for you and an opportunity to grow your business and generate more savings for the customer, better operations for the customer, and revenue for you. This is the top half of the screenshot of the VFD Contractor Incentive Program. This form is on our website and I believe will be posted in the chat. The crux to the program is Efficiency Vermont will pay contractors $10 per horsepower for properly identifying VFD opportunities in the marketplace. You'll see in a couple more slides the information that we're looking for. That's the upfront portion of the payment. If the project that's identified is approved as eligible end uses and then goes on to get installed and commissioned properly, the contractor will receive an additional $20 per horsepower on the back end of the project installation once everything is done and properly commissioned. The commissioning piece is very important for us. Our agreement with the Department of Public Service says that if we don't have a functional testing form for each VFD, we take a 10% savings hit on the project on that particular VFD. So we're trying to use this program opportunity to make sure that the VFDs that are installed are properly tuned to deliver energy savings. A VFD is a sort of box of electrical components. It draws power. So if you were to say put a VFD on a motor load and just let it sit at 60 hertz, you would actually be adding energy to the load that it's controlling. It's approximately 3% of the load that it's connected to. So if we don't make sure that these VFDs are modulating and turning down something below 60 hertz, the program requirement looks for an average of 54 hertz modulating. If you don't do that, we're actually doing the customer a disservice. We're adding energy to their base load, and that's not the point of the program. So the functional testing piece is very important. We're working on that form right now. There's a meeting Monday, and we expect to have a functional testing form available in the next few weeks. So how does the program work? Contractors review existing pump and fan inventory at customer sites for VFD application. There'll be a table and another slide or two that points to the 7 end-use applications that cover probably 95% or greater of the pump and fan loads in HVAC. Where applicable, contractor completes and submits the VFD contractor incentive form and sends it to pics@veic.org. That kicks off an internal process that sets up an opportunity in our system. It flags the account manager, who will work with our engineering colleagues and make sure that the end-use applications are eligible. If it gets a thumbs up, the contractor will receive a check for $10 per horsepower for the total horsepower of the project. And again, reiterate, the $20 per horsepower is paid on the back end after successful installation submission of the functional testing form. It's important to note that this program is additive. It stacks upon the existing VFD program, which we announced in 2016. Efficiency Vermont has a long history of being first in the nation. I think we were the first efficiency utility back in 2000. We've tried to really maintain a competitive edge and really have advanced programs. And yet when we announced in 2016, when we did the research for the VFD rebate program, we realized in New England, we were really the last one to the game. So we felt as a small state that we had to have something really aggressive to promote VFDs in Vermont. We came up with a program that is $150 to $200 per horsepower. And while we don't market it this way, that is intended to pay for VFDs. We did see an uptick in pricing during COVID, just lack of supply and demand held constant and pricing went up. I feel from conversations recently with suppliers and contractors that that's softened a little bit. And certainly in larger frame sizes, 10, 15, 20 and higher horsepower, $150 a horsepower typically pays for the drive. So that is payable to the end use customer. It's form on our website right now. You'll see the table in a minute for the eligible sizes and end use applications, but important to note that this contractor incentive stacks upon this $150 to $200 per horsepower rebate. So what details are required? We need your information, contractor information. We need the customer information. We also need their utility account number. That's how we tie it off in our system. And then we need details for each drive application. So a description, it's a chilled water pump. It's in the boiler room. It's obviously a pump. It's 5 horsepower. And then some motor tag information, frame size, insulation class is really important. You don't want to put VFDs on motors that don't have the proper insulation class. They need to be inverter duty rated. And this is just a way for us to verify that, yes, the motors are inverter duty rated. If it's not the end of the story. We could entertain a motor upgrade or a smart pump that has an integrated IE5 motor and VFD along with it. The nominal efficiency on the motor tag, the enclosure type, the RPM. And then this is important, these last, second to last column, the proposed VFD control. How do you propose to control the drive? The most typical are delta T and delta P pressure. There could be instances where you might want a fixed drive setting of say 50 Hertz. We don't love those, but there are instances in the marketplace where that is the appropriate control strategy. And then in the notes column, just put some rationale about why you're choosing the proposed VFD control. Here's the table I've referred to a couple times. This is straight off of our VFD rebate form. These are the 7 end-use applications that cover nearly every HVAC application I can think of, with a very few exceptions. And you see the horsepower range covers most of what you'll see in Vermont. And I will stop there. I can't see the chat. Is there any questions, Bryn or Lisa, that I can address?
There are no questions at this time. I have uploaded the VFD form, and I will go ahead and upload the other documents that you have brought to this.
Okay. All right, I'll give it another 30 seconds in case there's any questions, and I'll move on to IE5 motors. Shameless plug for our Efficiency Excellence Network.
We did get one question, Chuck.
Yep.
We have a question. Manually operated VFDs or a fan, for instance, still provide some savings through soft starts. Would those count towards this at all?
Can you repeat the last part of the question?
Yeah, I think they're asking about VFDs for soft starts, asking if the savings that, the energy savings that would be gotten out of using a VFD for a soft start on fan, is that an eligible?
Yeah. Thanks, good question. We get this pretty regularly. So VFDs do a much better job soft starting a motor than a motor starter does, or a soft starter. That said, the limiting of inrush current is a very, very short duration event, often less than a second, at most a couple seconds. So the energy savings from the soft starting capacity alone is almost unmeasurable. Is it kinder to the motor and the bearings? Absolutely. You're not cold starting a motor full bore from 0 to 60 Hertz, in a second or split second. So it will have a good effect on the longevity of the motor, but soft starting doesn't actually save any real measurable energy. It's really important that the motor either modulate ideally on delta P or delta T or possibly flow. If there are instances where you have a constant speed fan, for example, but the fan is oversized, there could be a case where you set the drive to say 54 Hertz fixed, there's no sensor controlling it, it's just running at 54 hertz always, it will save the intended amount of energy. It just won't modulate. And those are the types of notes that we would look for in that table that I showed a couple slides ago. We really prefer, in fact, the VFD rebate form requires a signal modulation, but upon exception, if there's a valid reason that it needs to be a fixed speed and that fixed speed saves a palpable amount of energy, we will support it. Thanks for the question.
No other questions at this time.
Okay, I'm going to move on to maybe my slides stopped working. There we go. Okay, so here's the IE5 motor rebate pilot program. Emphasis on pilot. We are running this pilot through the end of this year. Depending on the uptake, we may extend it into 2024, but we'll decide that later in the year. What are IE5 motors? IE5 motors are a two-step improvement over what we have had available here in the United States, at least since I joined Efficiency Vermont in 2007. In this almost 16 years I've been here, we have never been able to offer motor rebates, which is very ironic because 75% or more of the connected load in a manufacturing facility is motor load. And then in non-manufacturing, a lot of the connected load, aside from lighting, is motor load in HVAC and refrigeration and other equipment. So a lot of what we have on the grid is motor load, and yet we haven't been able to provide motor rebates. And the reason for that is that the federal government made NEMA premium efficient the federal standard. It might have been 2007 or one of the years shortly before that. So in the United States, all you can sell are NEMA premium efficient motors. Those equate to an IE3 motor rating. In Europe, they typically have standard energy efficiency standards that are a bit ahead of ours, and that is the case with motors. So the motor manufacturers have been making motors going into Europe that exceed our NEMA premium efficient standard, and they use a different motor efficiency rating system using the IE3, IE4, IE5. So we're essentially moving from IE3 to IE5 now, which is a two-step jump, which is very exciting for us because we have a window of opportunity now between now and whenever the federal government, US federal government decides that IE5 will become the new standard. I don't have a crystal ball, none of us do. We probably have a few years, at least maybe a little bit more, to take advantage of motor retrofits and motor replacements with IE5. So this is the top half of the form. You'll see the watermark draft across this. We're very close to having the final version. It's in with legal and marketing right now. We don't expect really any change on this. And I believe, Lisa, you're going to put this form or the updated one in the chat for the group.
I have put the final one in the chat for the group.
Thank you. So some details about the pilot program. These motors are only just becoming available in the United States. We've worked pretty closely with one of the first market movers, and that would be ABB Baldor. They're one of the major market shareholders. We expect WEG and Marathon and others to follow suit very quickly. Motor manufacturers have variety of lines of businesses, and what we've seen so far is that a lot of their early efforts have been with package equipment manufacturers like GreenHack and RTU manufacturers. So they're trying to strike agreements with those companies to embed their product in there. The purpose of this program is more the retrofit and replacement market. The higher efficiencies for these new motors are achieved via new rotor design and corresponding controls, while also maintaining the reliability, serviceability of the induction motor. They're made in multiple NEMA frame sizes from 140T to 215T and speeds up to 4,000 RPM. I will say I've seen a couple of 20 horsepower HVAC motors out in the marketplace in the 250 frame size, and the corresponding IE5 motor is in the 215 or 210 class. That's going to be a little bit of a mismatch in terms of shaft position. So these aren't a slam dunk. Careful thought needs to go into replacing motors with IE5, and that's one of the reasons that we're asking you to let us know about the motor frame size, the motor RPM, and some other details from the existing motors going to IE5. Lots of savings is possible. I'll show you a table in a moment. Let's get to that. So this is the scope of the pilot. You see it spans from 1 to 20 horsepower on the left-hand column. And the second column from left, you'll see the incentive by horsepower. These incentive dollars are intended to close the gap between the cost of a IE3 motor or NEMA premium efficient and a new IE5 ultra premium efficient motor. So when you're looking at a motor replacement of, say, a 5 horsepower, I'm just going to pick a number. Maybe that motor is $800 and the IE5 motor would be $1,200. We're offering $400 to basically make it cost neutral and help you get the customer into the ultra premium efficient motor. In columns 3 and 4, you'll see the delta in nominal efficiency. This is the name tag efficiency on the motor, and it is the full load rated efficiency. The savings on the right side are in dollars. The kilowatt hours behind that are predicated on the delta between efficiency in column 3 and 4, and a motor running at 18,000 RPM and 15 cents a kilowatt hour for 15-year motor life, which is pretty typical lifespan and prevailing cost of electricity for HVAC customers. Excuse me. Very important point. IE5 motors require a variable frequency drive to operate. So if you have an existing IE3 motor, IE2 motor, and it doesn't have a drive, you're entertaining a motor drive upgrade, not just a straight motor swap. To make matters a little bit more careful, let's say, any existing VFDs must be capable of operating permanent magnet motors, which are the IE5 motors. So there's a little extra homework here, and we will help you with this. I came from a customer in Brattleboro a week ago. They have Siemens drives that are only about 2 years old. So there's absolutely no reason to swap those drives out. They've been paid for and are saving a lot of energy and are in good shape and well maintained. To put an IE5 motor in there, we have to do some extra checking between ABB Baldor and Siemens to make sure that these new motors and the existing drive are compatible. That takes an extra step, but we're happy to help make the connection between the two manufacturers. And as time goes on, we will see tables come out where IE5 motors are proven to be compatible with drives from Danfoss and Westinghouse and all the prevailing drive manufacturers. The table I just showed a minute ago, I'll flash back to it for a moment. The savings on the right side here is predicated on full load efficiency operations. So that would be a pump or a fan running at full load throughout the course of its normal hours in a given year and a given lifetime. One of the things that we're very eager to understand from this pilot program is the part load efficiency of these IE5 motors. This is apparently where they really shine. The more you slow them down, and they all are required to be on drives, so they will be in a position to be able to modulate, and they'll be operating at part load efficiency, they actually gain even more savings. So eventually this savings on this right-hand column should be significantly more when we graduate this to a full-blown prescriptive program, because we will be taking advantage of the part load efficiency. We're going to do a bunch of pre and post metering on a lot of the early projects to understand that part load efficiency gain and build those savings into the program as it matriculates onto a prescriptive program, possibly in 2024. I would think certainly by 2025. Couple key points here. Back when I was talking about the VFD contractor incentive program, we were talking about 7 end-use applications. The motor applications in this program are the same 7 minus the cooling tower fans. And the reason for that is the IE5 motors that we have available today are not waterproof, and we don't want to risk putting these in damp locations and having motor failures or worse. The eligible criteria is 1 to 20 horsepower. These HVAC end-use applications, those being supply fan, return fan, boiler draft fan, water source heat pumps, circ pumps, chilled water pumps, and hot water distribution pumps. Motors must be new, must be VFD compatible, or upgraded to become compatible with the new motor. Customers must provide the make and model of their existing VFD when submitting their motor rebate. This is to make sure that we take the verification step to make sure the new IE5 motor will work with any existing VFDs. And as with most of our projects, Efficiency Vermont reserves a right to install meters for savings verification and to access motors pre and post replacement. That's a big piece of this pilot program. We are learning. We've learned a lot about these IE5 motors, but we still have more to learn, particularly around the part load efficiency. Some keys to success for you as contractors. Consider using these motors for pumps and fans that either have a VFD or would benefit from a VFD. So we're purposely launching these 2 programs together. We're promoting you going into customer facilities and documenting VFD opportunities. But if you realize the motor is inefficient, it's old, maybe it's got some mileage on it, there is an option to order a integrated drive motor combination from the likes of ABB Baldor and others to come. So it could be an upgrade of both the motor and the drive, which gives the customer 2 points of energy efficiency improvement. Can't belabor this point enough. Ensure drive and motor compatibility with motor, drive manufacturer, reseller, installer. So there's often a variety of folks involved in the supply chain. There's of course the OEMs, there's resellers, there's contractors. Make sure you have good communication up and down that line to make sure that these new motors work with the existing drives. If you're ordering an integrated motor drive package, you don't have to worry about it, that they're pre-set at the factory and they're certainly compatible. But for existing drives, you want to take an extra moment to make sure the compatibility is there. And of course, as always, with all of our business with you, leverage your relationship with Efficiency Vermont. We can help you with eligibility, savings analysis, rebate, pre and post motor replacement savings verification. We're your partner through all of this, through every step of the way. We want this program to be successful. According to our colleagues at ABB Baldor, Efficiency Vermont is the first in the nation with this program. So we want to do a good job. We want to learn from it, and we want to graduate it to a prescriptive program as soon as possible.
Sure.
I will stop there.
We do have an additional question in the chat coming from Joshua again. I think he'd like a little more clarification if he didn't already get it from your last statement about if the existing VFD will not work and must be upgraded, can the new VFD be eligible for the VFD incentive?
That's a very good question. I think on a case-by-case basis, we can support that. I think the hurdle we will have to clear is the same hurdle that we have to clear when a drive fails and or a customer wants to replace a drive before it actually fails. And that typically comes down to measure life on the drive, or how long has a drive been in existence. If, for example, the drive that won't work with the IE5 motor is only 2 years old, and we paid an incentive and claimed a savings on it 2 years ago, we may have an uphill climb on that one. But if the drive is 10 years old or older, and it's still working, but it won't work with the new motor, we probably have a justifiable end of life discussion. There are customers out there, very sort of forward thinking customers, who say, listen, it's been 10 years, my drives have been operating, I know they're nearing their end of life, I cannot afford for them to go down, so I'm going to proactively replace them. And if that replacement ends up becoming a motor and a drive to gain efficiency on both, then I think we have a clear path to support the motor and the drive. But if that drive's only been out there for a short amount of time, we'll have a little bit of an extra hurdle. I won't ever say no. We'll always go to bat for what we believe is a good savings project. In your question, in your example, if the new motor requires a new drive, I think we would go to bat for that with department, explain the situation, and try to appeal to a higher sense of efficiency. That's the only way that motor is going to get in there is with a new drive in that example. Lisa, are there any other questions?
There are not at this time. I'm hoping we clarified that question for Josh, but I am not seeing any other questions in the chat at this time.
Okay, Lisa, I don't know if you're going to distribute this deck, but I put an appendix in the deck, and I just wanted to point out this slide for the folks on the call because it's a good, particularly the rule of thumb on the upper right box. So you've heard about 2 programs today. This one really speaks to the VFD program. I have a much longer VFD sort of 101 training deck, and I pulled this slide from it because as you go out into these customer sites and you're looking through their premises, their boiler rooms, their air handlers, and you're assessing, now like if I can find $100 100 horsepower worth of motors in this facility, and I turn in the form, I can get $1,000. That's purposely designed to help you with your service work. You're sending techs there to go do a PM. Those techs cost a certain amount of money that you're getting paid through the PM. If they can come back with a form that documents 100 horsepower and then get $1,000 for your company, that's a nice bit of gravy on top. I walked through this just to trial it with a contractor. It took about 45 minutes of field documentation and about another 45 minutes of desk work to fill out the form and submit it. So an hour and a half, we documented 58 horsepower. That customer's going to get, that contractor's going to get a check for $580 for essentially an hour and a half of work. Now, that's one side of it. That's your sort of revenue, upfront revenue making component. The other piece is, the value proposition for the customer. And the rule of thumb for HVAC applications with drives is when they modulate down to an average of 54 hertz, you're looking at about $200 per horsepower in annual savings. So back to that example, we found 58 horsepower. My math's not that good, so I'll round it up to 60 horsepower. That's $12,000 a year in potential energy savings for that customer once they put the drives in on those 58 horsepower worth of motors. So it's just a good rule of thumb. If you're talking with a facility manager or owner's rep or owner themselves, and they're saying, why would I do this? It's some pretty quick field math that you can tell them, this is why you'll do this. It'll save a pretty nice amount of energy. And again, back to my original point, there's not much out there like VFDs in terms of turning up savings. Just slowing down motors even a little bit really produces savings. So there are more slides in the appendix that you may want to look at if this deck gets disseminated. And if there are folks in the audience who would like VFD 101 training, I'm always happy to give them. Thank you.
And Chuck, I was able to upload the deck to the chat. And just for all the participants, if you are not able to access any of the documents I have uploaded to the chat, you can reach out and we can